your magnetostrictive transducer. As we have seen, the Hall's effect, that is nothing but the opposing force that has been generated due to the magnetic field. On the similar aspect, this is working. Then what is happening in this lead here? When we people are applying a magnetic force, or when we people are trying to generate the magnetic field, and vice versa. So magnetic field and mechanical energy, either you are providing mechanical energy to generate the magnetic field, or providing magnetic field to generate the mechanical motion or elongation of that particular aspect. So introduction to that particular aspect, then its history, it is very interesting type of transducer, its working and references. After completion of this particular lecture, the lecture outcome is that you people will be able to elaborate and differentiate the different concepts that has been used in magnetostrictive type of transducer. The application based upon the actuation and the motion using your magnetostrictive type of transducer. And finally, the working of the magnetostrictive transducer with one of the case study in both the manner, either by keeping your one of the phase constant to move towards the saturation. Okay, so one of the case study which we people are going to see with one example also, that I will provide to you people. Now, uh, here, actually, what is a magnetostrictive transducer? So you people have already studied Hall's effect and Hall's effect for the displacement measurement. In that one, the opposing force, depending upon the motion of the target, actually how that electrons and all these things were moving, I have shown the video also of that particular aspect. So if you try to recall the Hall's effect, it is somewhat similar to your magnetostrictive type of transducer. So what actually your magnetostrictive transducer carry out, that is nothing but it will try to convert the magnetic energy to a mechanical energy, and inverse to the mechanical energy to the magnetic energy. In both the way, your magnetostrictive transducer is working similar to that of your piezoelectric crystal. Similar to that of your piezoelectric crystal, it means that it is acting as a transducer also, and it is acting as an inverse transducer also. So as per the definition, magnetostrictive material transducers are that converts a magnetic energy to the mechanical energy, or mechanical energy to the magnetic energy. So as your magnetostrictive material is magnetized, suppose I am having a magnetic some magnet in my hand, and if I try to place the nail, iron nail on that magnet, after some time this nail will also have some of the power of the magnetic field, some of the power of the magnetic field. You practically even execute. If you are having a magnet at home, you just try to place across some nail, a small nail or pin, and place that nail or pin on the magnet. You people will get the magnetic field or that particular energy, so that it will try, if you try to remove from that particular magnetic field and try to place nearby some iron part or some magnetic iron cores, so it will try to attach, or force will be exerted to move towards that iron depending upon the weight. If it is having a higher weight, your hand will be forced to move towards that one. If it is lighter than that, whatever you have accomplished on the magnetic field, it will directly grab or with the force. And on the same principle, it is working. So as your magnetostrictive material is magnetized, after magnetized, it strains, it exhibits a change in the length per unit length. So change in length. Now, suppose one pin which we people are using for the paper. So there are large number of pins that are specified. If you are trying to bring a magnet near by that particular pin, you will experience that pins will try to force and move towards the magnet depending upon the strength of magnet, but its length are changing. Its length are changing. Length is not going to remain same. Length means not the length of that particular pin, but either randomly it will try to be suspended in the straight manner. In that manner, actually, suppose your pin, suppose this is your pin and here is the magnet. So this will be attracted, but your pin may be represented like this. So the length has been changed. Actually, the length was considered as a width in the normal condition, but at this instant it is not showing this one, but this much is the length that has been changed due to the magnetic field. Okay. So conversely, if an external force produce a strain in a magnetostrictive material, material's magnetic state will change. As I have already specified that when you are coming across some motivated persons who is always thinking in the positive direction, at that time your thoughts get energized. Your thoughts get energized and you people are getting the boosting of the positive energy. Similar is the case over here that as you people are charged with a positive thoughts, in the similar manner, when that magnet is coming across the metal, it will try to transfer its some of the energy, or the sum of the energy will remain in that iron core or that pin. So it will be magnetized. That will be magnetized and it will exert a strain. Okay. So the state is going to be changed from normal state to magnetic state. No doubt it can remain for very small time of duration. So what was the strength of the magnetic field which it has been came across? Depending on that, its magnetic strength or time duration is going to be last. Now, as it is bidirectional means in both the way it is working. So the bidirectional coupling between your magnetic and mechanical state of magnetostrictive material, that will provide or that will give you transconductance capability, exchange capability used for both actuation. Actuation means suppose I am having one switch. I want to start that switch, means we are activating that particular switch. And another one is the sensing device. So here using your magnetostrictive material or magnetostrictive transducer, you can work in either way, that using the magnetostrictive field or magnetic energy, you can make the switch on or off, or either you can develop a sensor to work as per its need. How it is with that particular example, I will clarify your points. So magnetostriction is an inherent material property, and as it is having the inherent material property, there is no degradation with respect to time. So we are not going to get any degradation or the loss